Hi there, welcome to our first lesson in our C5 topic of how much, which is all about quantitative chemistry. So there will be quite a bit of maths involved in this topic, and there will be a lot of maths in this lesson as well. Anyway, I hope you enjoy it, and I'll see you at the end. Bye-bye. Okay, so our objectives for this lesson today are for moles and masses. By the end of this lesson you should know and understand what a mole is in terms of the number of atoms of a substance, and what the term relative atomic mass and relative molecular mass mean. The relative atomic mass is sometimes referred to as RAM or RAM, and relative molecular mass is RMM. The term mole is something that we refer in chemistry as the amount of a substance that we've got. Now, when we're looking at reactions, we tend to focus at the moment on atoms and molecules, when in reality you're talking about particles that are so very small that it is impossible to actually do it with one or two of those. So we actually look at a whole group of molecules. Now, this is what we refer to as a mole. Now, the molar mass is the relative mass compared to other chemicals. Now, what we tend to focus on is something called Avogadro's number, which has the symbol L, and this is 6 times 10 to the 23, and that's how many particles, atoms, molecules that there are in 1 mole. Now, from that we can work out what the molar mass will be. So the molar mass will be the mass of the atom times this number here. So what we'll do is we'll have a quick look at a couple of examples. Now, here we have from the periodic table the element sodium. So we've got Na, which is the symbol here, we've got 11, which is the atomic number, and this here is the mass. Now this means that its relative mass is 23. Now if I just move that there, now that means that if we had 6 times 23, oh, hang on, that's wrong, 6 times 10 to the 23, let's delete that, so 6 times 10 to the 23 atoms of sodium, I would have 23 grams of it. And that means that the mass of sodium is 23 grams per mole, and that's the units for relative atomic mass or relative molecular mass. Now, how we actually work out a number of moles that we have, it's made with a comparison to the mass of carbon-12. Now, it's all relative to how much that is. Now, 12 grams of carbon-12 will have, as we've said, Avogadro's number of 6 times 10 to the 23 atoms within it. Now, we can work out the number of moles using a very simple equation, and that is the number of moles is equal to the mass divided by the molar mass. So we can work out how many moles we have if we had 112 grams of iron. Now, I'll go through how we do this. Now, N, this number of moles, is equal to the mass, so we've got 112 grams divided by the molar mass of 56, which means we have 2 moles of iron. Now, if we have a look at another example, if we had 230 grams of ethanol, which has a molecular mass of 46, then 230 divided by 46 would equal 5 moles. Now don't forget, you need to be able to rearrange this equation to work out either the mass or the number of moles. It's rare that you'll be asked to work out the molecular mass. Now the relative molecular mass is where we have molecules of different with more than one atom. So we'll have a quick look at oxygen to start with. Now oxygen has the formula of O2, which means there are 2 times an oxygen atom. Now if we look at the periodic table, we can see that oxygen has a mass of 16 grams per mole. Now because we've got 2 of them, we do 16 times 2, which equals 32 grams per mole. So that is what the relative molecular mass of oxygen will be. We can do some other molecules which are a little bit more complex. Now the first one we'll do is sodium hydroxide. Now the atomic mass of sodium is 23. Oxygen, as we've just seen, is 16, and hydrogen is 1. Now if we add those all together, okay, so we've got 23 plus 16 is 29, 39 plus 1 is 40 grams per mole. Now the next one we will look at is magnesium chloride. So if magnesium chloride has this formula. So magnesium has a mass of 24 grams per mole. Chlorine has a mass of 35.5 grams per mole. Now if we look here, we've got 2 atoms of chlorine, so we have to multiply that by 2, which gives us a value of 71. Now 71 plus 24 is going to equal 95. So we have a relative molecular mass of 95 grams per mole. Okay, we'll do one final one. The last one we'll do is magnesium hydroxide. Now magnesium hydroxide has the formula MgOH2. Now this means that we've got OHs, we've got 2 of them. So Mg, as we've just seen, is equal to 24. O is equal to 16, and H is equal to 1. Now these we have 2 of. Now they add up to 17, and 17 times 2 is equal to 34. So 34 plus 24 is equal to 58 grams per mole. Okay, now I've just put on the screen now a couple that I'd like you to have a quick go at. Now obviously I've not been able to get these as subscript, but these are the formulas for 4 that I'd like you to have a go at. So we've got sodium chloride, calcium carbonate, phosphoric acid and sodium carbonate. Now conservation of mass is really very simple. Basically, whatever we have on this side of a reaction, we must have on this side of the reaction as well. Now what we'll do is we'll have a look at the molecular masses of these compounds here. So we've got calcium carbonate, so we've got the formula CaCO3. So calcium is 40 plus 12 plus 3 times 16. Now that adds up to 100 grams per mole. Okay, now on the other side we've got calcium oxide plus we've got carbon dioxide. Now the calcium oxide is 40 plus 16, which is equal to 56. And then we've got carbon dioxide, which is 12 plus 2 times 16, and that is equal to 32. 32 plus 12 is equal to 44. Now if we add the 56 and the 44 together, we've got a mass of 100 grams per mole. So 100 grams per mole will make 100 grams per mole on this side. So if we were to take 100 grams of calcium carbonate and we wanted to know how much calcium oxide we should make 56 grams of calcium oxide and 44 grams of carbon dioxide. Now if we had 50 grams of calcium carbonate, which is obviously half the amount of 100, we'd make half the amount, so we would make 28 grams and 22 grams. Now we're going to have a look at the reacting ratios. Now if we look at this reaction where we have copper sulfate reacting with sodium carbonate to make copper carbonate and sodium sulfate, we can look at the masses involved. These are, now we have 159.5 will react with 106 grams to produce 123.5 and 142 grams. Now these ratios are the same, so whenever you have 159.5 grams of copper sulfate, you're always going to make 123.5 because of that conservation of mass. Now if we were to treble that, we would then have 478.5 grams of the copper sulfate, and that will make 370.5 grams of the copper carbonate, and it's the same with the other two as well. So that's the end of this first lesson on C5. There is quite a bit of maths to do. I hope you've had a go at the 4 problems that we've done earlier on, and just concentrate on the maths, and we'll see how that goes. Anyway, I hope you enjoyed it, and I'll see you later.